Hey everyone, it is my pleasure to host Frost Sullivan's Growth Webinar today on Agentic AI in Industries. I have with me two distinguished panelists from the industry, Daniel Siegel, co-founder from Cinera, an AI agents platform for engineering automation, and Dan Jeevans, president from Applied Computing, a foundation AI platform for energy operations. I'll let both Dans introduce themselves. Maybe to start off, Daniel Siegel from Cinera.
Yeah, thanks, Karthik. Super thrilled to be here. Thanks for the invite. As you mentioned, I have the honor to be the co-founder and also working every day on the vision to make Agentic AI ready for engineering. So our vision for the company, I don't know how many Tony Stark fans we have here in the audience, is for sure, making Jarvis a reality. I've seen that a lot of startups now have Jarvis as vision. At least, hopefully, I can claim we have it since 7 years. So we're working pretty hard on this vision. And now with all the, let's call it co-evolution on the large language models and all the stuff that happened in the last couple of years, it fits perfect together to us, where we help the tools, all the legacy tools that we have seen in engineering, to make them agentic ready, and now everything fits together. So I have the feeling we are closer to this reality than ever before, and I'm super thrilled to discuss all these kind of topics in more details in this audience.
Wonderful. Dan Jeevans from Applied Computing.
Super. Well, again, just thanks so much for having me. It's great to be with you. In terms of my background, I spent a long time developing AI for the energy sector, and I'm still doing that now. I spent a little under 20 years at Shell in a variety of different forms, developing AI solutions right across the energy value chain. We didn't call them AI when we started, but really it's been the same theme, the application of advanced data-driven methods, and now increasingly physics-inspired methods to improve energy processes. Here at Applied Computing, we're developing a foundation model for the energy sector, specifically for energy operations, looking to rethink the way in which we can operate the most important facilities in heavy industry, I would argue. It's very exciting, and I'm sure we'll get into it more.
Wonderful. It's such an honor to have both of you from very, I would say, eclectic backgrounds, all talking about, I think, a very important topic, which is agentic AI. That has been, I would say, the buzzword for 2025. I just want to get a bit deeper and get a bit of nuance onto the subject and understand your respective positions. So my first question would be, what do you think makes AI truly agentic in your respective domain?
Dan, do you want to start, or shall I?
I can start. Go on. I'll jump in and get us kicked off here.
Cool.
So what I want to maybe start with is kind of how we look at the world, which is perhaps a bit unique. And I think it's important, in my view, to differentiate between foundation models and agentic systems. And I'll start with a bit of a definition. Daniel, I think there's probably a few of these out there, so feel free to disagree if you disagree. But I think for me, the foundation model is really a general purpose model that has a variety of different capabilities and can answer a whole range of different questions. It's trained on, and can be one, can be several different data sets, but it really acts as a general purpose capability. But it's not specific to one particular task. For me, the agentic system is a system which takes those foundation models typically, may also take other models that are not necessarily foundation models, and integrates them into an orchestrated set of tasks, which is designed to achieve a specific outcome, a business outcome for a customer. That's how we look at the world here at Applied Computing. Now, if I sort of unpack that a little bit in terms of how we see our world and how we are developing agentic systems for the energy sector, what we're looking to do is develop a foundation model that is specific to energy, but it's also physics inspired. And then through a variety of applications, adapt that through agentic systems to drive specific outcomes in specific contexts for customers, which we call products. So that's how we look at the world. But Daniel, very interested if you have a different view or if there's any nuance you want to add, or I can also learn on this one because I think we were all learning.
No, I think you nailed it. So when people ask me what's for me agentic AI, I always say it's for me an agent consists of three different parts. One is the foundation model or the large language model in general, and there are multiple ones out there, and it's great that you are working on your own one here. Second one is for me the context, right? Where is this model then operating in, and not just the context that get learned with, but also maybe additional context which is outside of the foundation model, which also includes memory, company knowledge, reg, all this kind of stuff that we normally use as technology to make them more aware of the specific context these agents should operate in. And then the third layer, at least for us, this was the game changer layer, was this kind of access to tools, so that they are able to control applications that we normally use to finish a task, how you mentioned it, right? So I would also say, when you look at it and you want to increase the quality of an agent, you have to increase the quality of the model, you have to increase the quality of the context, and you have to increase the tool layer to make sure that they are more versatile, more error prone, they are just working for the systems. And then the question is, okay, what is the agent capable of, right? If they just have one tool, one context, and one foundation model with one task, can say maybe it's barely intelligent, right? It can make one task in a fancy new UI that you chatted instead of using a graphical user interface. But I think when you, give them more ways to judge and to decide which way to go, then you come closer to this, oh, that sounds smart, right? And you have it normally already in the foundation model because of the model modality. But if you want to give agents also the freedom to judge a little bit more, you have to make sure that they have more options to choose, like more access to tools. And they have the rights to decide which tool they can use when.
Very interesting. Can you elaborate on the context part, your second layer?
Yeah. I mean, for me, context is again everything what is addition to the foundation model. And especially in engineering, what we see is the context is normally inside of the companies and it's normally locked, right? Because it's their intellectual property, it's their way how they're doing things, it's their Coke recipe to have their competitive advantage. And this is one challenge. The second challenge is that in engineering, most of this knowledge is even in the heads of the engineers. So it's not in the Git repo that we know in programming or computer science. It's also barely in any PDM, PLM, or other stuff. So what we heard, even if they have a process, if you ask the real expert to say, yeah, well, we have this written down, but to be honest, we are doing it this way. So, okay, but this is not written anywhere. Yeah, you're right. You have to ask, I don't know, John. He's the expert. He's there for 40 years. So it's very hard to increase the context in the engineering domain. And I think this is also a big, homework for all the engineering companies out there that would love to benefit from this technology to make sure they have a context strategy, how they make the context available to large language models to benefit from the era of digital coworkers. But I'm super thrilled to get Dan's view on it because I think context is really a tricky one, and also probably is the same as you also need as training data for your foundation model, right? So I'm curious about how you get the extra layer of modality into your models.
Yeah, and maybe Daniel, I'll pick up on where you left off, right? Because I think this is exactly some of the. So let me start by saying I completely recognize the challenges, right? I've spent similar years working in similar contexts with similar challenges, and I think that access to experts is particularly challenging. And I think what we've maybe started working on the foundation model for exactly that reason, because we believe that actually the needs of engineering, I will say specifically for us in the energy space, which I think is slightly different to manufacturing. So I just want to lay that out straight up. But for us in the energy space, you're exactly right. There are decades and decades and decades of expertise that are typically locked away in the heads of specific users or specific experts within these systems. The reality, though, again, within the industry that I know best, is that oftentimes this isn't like the Coke recipe secret sauce, but actually it's quite well understood science. So if you talk about fractional distillation, it's not some rocket science that no one understood. Most of us will have learned it at some point during our actual high school education. Certainly I did. And so the point being is this type of science is there in the public domain. It's well understood. The physics that govern it is well understood. But if you go to the large language models today, which at the end of the day are nothing more than sequence predictors, they actually tend to do a very poor job of dealing with this. And it's really two reasons. One, they're not great at dealing with time series numerical data. And the second thing is they were never really designed to estimate, if you like, calculations on the basis of physics equations, which of course is at the heart of everything that we do within engineering. And so for us at Applied Computing, what we've been trying to do is really rethink the paradigm of how do we integrate those different data sets, those different sets of information is probably a better way of putting it, into a new type of model that you can use as a foundation to build these agentic systems. And so what we've done is we've developed an integrated system that, and I think, Daniel, we were talking earlier on about let's not build foundation models. We agree with you on the LLM side. So we don't build LLMs either. We look to take the best LLMs that are out there, and that continues to improve all the time. But we augment that with additional capabilities, specifically around physics and time series. And the final thing that we do is we make it anti-hallucinatory. So we make it say, if I don't know, I say I don't know, which is very fundamental within an engineering context, because rather than trying to please the human, as we see within most of the chatbots that are out there, we want to make sure what the model says is accurate. And if it's not accurate, it shouldn't say anything. So this is the difference between what we're developing here at Applied and the standard system. Now, what that does is, and I think Daniel links to your point, when we have a model like this, we can bring it into that context. And rather than bringing in, if you like, a model that requires the engineering context to be overlaid onto it, we bring a model that understands the context that you're bringing it into, which means you can train it that much quicker and develop agentic systems with it that much faster. So we think this is a really exciting breakthrough, certainly for energy. And I think it's also, we'll see more of this going forwards, because I think in particular, physics-inspired deep learning is going to be a very important part of the next generation of these systems for engineering.
Can I ask some follow-up questions? Because you hit my heart. So I have a lot of questions, and I really like the explanation you gave, Dan. One would be, if you augment this, and this would be probably my second question, what do you mean with augmenting, right? So what is, maybe you want to share something, how you do it, your secret sauce here, but that would be interesting. And the second one is also, you still need test or data sets, right? So, and
Absolutely.
it's still probably your customers' data you're required on. Maybe you can give us some,
Yeah.
I would be keen to understand if you use techniques like federated learning or other approaches, or I don't know, collaboration approaches, how to make sure that you get access to these data.
Yeah. I think great questions, right? I think let me start by saying, maybe start with the second part first. Typically, what we end up doing is we end up working first within our own environment, proving it on publicly available data sets, demonstrating that that works. Actually, there's a lot of publicly available data, which gives us the ability to then do some transfer learning. So we bring in certain context with us, certain, particularly around the language models, certain learned elements. We also bring with us, if you like, a templated physics and time series model, which we know works well in the environments that we work in. We have them tuned for the types of industrial assets that we're working with. So you think about this differently if you're in an upstream context versus a refining context versus, when you're talking about wind turbines, for example. And what we try to do is bring those models into that environment. And then, of course, to your point, we then have a whole range of customer data that's specific to their context. So just as you would treat that as context, so do we. And we try and bring that in and then augment we effectively do, as I said, transfer learning in, and then we fine tune is probably the best way to describe it, the model within that framework of the customer's environment, specifically to their unit. We also establish a very clear context. So we're not trying to solve world hunger with this model. We're trying to solve a very specific problem within a given context, within a given engineering unit or multiple units. and then to be able to solve specific problems, as I mentioned, by transferring that into an agentic system. You asked another question that slipped my mind, Daniel. Can you remind me the first question that you asked?
Yeah, when you say you're not building an LLM or foundation model, the question was, okay, what are you putting on top? What I understood now is
Yeah,
that you have a
great.
general fine-tuning and then a
Yeah,
fine-tuning customer specific. So it means you have foundation
correct.
models different for each customer. Is that correct?
Effectively, well, I would say with some yes and no. We fine tune an existing model that we have within a customer's environment, and we also use our own RAG approach to make sure we're able to develop the agents within that environment. So it's a
Gotcha.
combination of foundation plus our own tuning plus customer fine tuning plus then RAG as I think most people would do within that environment.
Yeah, cool.
Very, very interesting. So, can you elaborate on this aspect of, again, I'm going to the context pivot here. So, by context, do you also include expertise? For example, I think one biggest reason for agents or interest in agents is the exodus of experts that is happening right now in the industry. This includes both energy, traditional manufacturing as well. So, is there a way, do you think the expertise could be coded? And is that also part of the context?
For me, yes, but I think also here everyone has slightly different definitions. So from my point of view, I always count three big categories into context. One is the instruction, also the prompting, and all of this stuff is also for me a kind of context. The second one is memory. Like, okay, I can have, I don't know, session memory when I just have one session with an agent, but I can have global memory, I can have a company memory, I can have memory on different layers. And then
Hmm.
this goes also a little bit into your direction of the question, how to make sure that you capture the knowledge of your experts, right? Probably memory is a good strategy to do so. First of all, when they're engaging with the system learns over time. You can also make strategies like onboarding sessions as you would normally onboard somebody, right? So it's say, okay, when you hire a new person, they also need an onboarding, right? So it makes sense to think also on onboarding for agents, and probably memory is a good way how to store this onboarding. And then the third is normally the company knowledge, and the company knowledge mostly best case is in a written format, or any kind of database, or at least structured or unstructured data that can be in somehow consumed by the agentic system. And then I think the challenge here is that we are all learned, I think, throwing everything in it doesn't make sense at all. So you now need good and smart strategies how to optimize your context, right? How to select it, store it, isolate it, capsulate it. And there are more and more, I don't know, strategies out there how to do so. So you see really that also the context layer gets improved rapidly, but I think there's not a silver bullet yet, but yeah,
Hmm.
maybe there are some. So I don't know, Dan, how you see it with context, but I think there's a lot of work still to do.
Yeah, I think so too. Maybe one thing I'll say to start with is I think, Karthik, it's a great question because, and I think, in most cases, the experts in the room in these environments tend to be nearing retirement age. We ran a study, and we came up with with an estimate that the average person working in a refinery right now is probably in their early 50s. And that gives you a sense of the fact that we have a population nearing retirement, and as a result, some of the knowledge is walking out the door. And I think that's a great opportunity for this type of thinking. And I agree with Daniel; it's a really important problem. And I'll also say I don't think it's fully solved, to be honest. That said, I think there is a lot that can be done. And again, I agree with Daniel on this. I think again, we look at this in a number of different layers, as I described earlier. So we look at it around the foundational training elements, which we can learn from publicly available data. We also look at it in the context of the specific problem that we're trying to solve. So being able to then bring contextual context within our foundation model that understand within a customer's environment with that fine tuning, the elements that they have put in place around their specific unit. Typically, you're dealing with, you can't just apply, even though, a DCU sort of a fractional distillation column for those that are not informed, are effectively being able to, those environments, those specific pieces of equipment are very complex, but actually quite bespoke. And typically they're produced by one particular company that's provided the license in the first place, just like an OEM or original equipment manufacturer within a refining context. What that means is you have to adapt to the specifics you're talking about in engineering. You can't just take generic context like you do in the web. You've got to be able to tune that very heavily to the specific environments, the specific units that you're working with. And so effectively, what we're looking to do within the way that we think about this is build layers on layers on layers of additional context, both in the foundation model and then the specific tasks that we build on top of that. And how you deal with that content depends on the problem that you're talking about, because it's actually different layers. And I think there's a lot of work to be done around how you optimize the difference between, as we referred to earlier, fine-tuning versus retraining versus RAG. All of these areas are different approaches that we're taking, but I think this is still going to continue to evolve quite a lot in the coming period.
Mm-hmm. I realize there's one aspect which has been conspicuous in terms of not being covered yet is the concept of DRLs. So do you see agents based on DRLs having a play in this space, or is it going to be mostly the LLM led ones?
Go on, Daniel, you go first on this one.
Well, what do you mean with DRL?
Deep reinforcement learning.
Okay, so
I think I
back.
can add a bit, I can add a bit of context. So when
Yeah.
the agentic AI discussion started in the industrial space, I'm talking about it, say 18 to 24 months back.
Yeah.
So much of the discussion was around using a DRL approach to arrive at agents that can help in, say, specific closed loop processes primarily. Now, that discussion has slowly started becoming replaced with more LLM led agents. So I'm just trying to understand why that's the case and what's your perspective or position on that?
Wow, good question. To be honest, in product design, we for sure we have enforced feedback loops, right? Where you can think about a similar technique that you mentioned with deep reinforcement networks. But in general, I think that was not a huge success, at least what I've seen in the last couple of months and years.
Mhm.
Because especially for us, we are in like an agentic builder, right? So, or we help customers to build their systems. So every job is different, right? We don't have the situation that we know exactly this is a job to be done that our customer want to do, right? In general, they want to have digital co-workers in the field of mechanical engineering, in the field of product development. So it's a very broad field, and for that you need a lot of different tools to do so. And back to your question, why this one technology was not so adapted as the other. I have the feeling that especially for this kind of, let's call it multi-job purpose, the reinforcement is a lot of extra layer you have to make sure that you really get benefit of. Or except you only, I mean, if you just use it for a feedback loop for your prompt and in combination with the large language model, then it's a different game. But I mean, there are also tactics that you use these kind of networks for physics problems or other problems, right? And here, I mean, that is in general what I see in product development. I mean, AI was not new, right? I mean, I remember I had AI in my studies in the early 2000s. We had, I think Dan mentioned it in the early days, it was not so often named as AI. It started with statistics and machine learning, and then it becomes more and more AI because marketing and the market also pushed us in this direction. But in the end, it was only a lot of effort to make one application really running in production because you had to make sure that you are close to the values that you normally need to be. And for that, it was a long way. And I think that really changed with the foundation model because you had this kind of modality in it. And they had this kind of multiple skills, not just one specific task to solve. So I think that is, yeah, my explanation for that. But again, in the area where I'm working in, that was never really this kind of big shift, at least what I perceived.
Yeah, and I'll pick up on that. I think it's really interesting. So I think, Deep RL has been through these multiple waves, right? In terms of its applicability in this domain. I mean, I remember the early excitement around the application to self-driving cars. Even more excitement when it came to the whole DeepMind application
Yep.
and AlphaGo. And I kind of rode that wave, and we did a lot of work, and I see some questions on this we can probably pick up later on around, we were looking to see, can DeepRL replace advanced process control? And largely we struggled with that, to be brutally honest, because the issue we found was it could, but it didn't actually beat conventional methods that were a lot simpler within the context that we were working in. And so as a result, I think, within the engineering context, there was a lot of excitement, particularly driven by the self-driving cars application, but it didn't live up to its promise quite as much as we thought it would. Interestingly, at Applied, we are using it, but we're using it in a quite unique way, which is we're using it as part of the verification system to capture the human element of the knowledge. So for us, where we apply it is that we look at it in that anti-hallucination layer, where we basically build a combination of a specific type of large language model along with human feedback, which effectively makes the model check itself properly. And there we found it extremely useful. And that's been the primary application for us in developing Orbital, which is the foundation model that we're working on.
Oh, that's very, very interesting. Now, just to pivot back to agentic AI. Now, for agentic AI to become a reality, we definitely need certain basic infrastructure layers that are available in industries. And I think one basic infrastructure would be some form of a cloud, which again has been a challenge in the industrial space. It's an elephant in the room that people hardly talk about. Now, how do you see agentic AI evolve irrespective of, say, a cloud native dependency?
So I have a lot of energy on this one, Daniel. I'll jump in and then you feel free to build on it. I think, look,
Sure.
I think what's really interesting about this journey has been, if you talk to a variety of different companies on this, they tend to be all over the map in terms of what they think about it, in my experience. The other thing is, I think that a lot of the conversation tends to be misguided because it tends to focus on the problem of industrial automation versus the problem of industrial intelligence. And those two are not necessarily the same thing. What do I mean by that? Let me unpack that a little bit. I think the first thing is that there's a lot of fear factor about the cloud within these organizations, in particular because most of the environments that we deal with are air-gapped, completely separated, and the control systems run on-premise typically. Now, you can argue, whether that's right or not, and you can argue the whys and wherefores of, OT security and whether that's the right approach. I think the key point, though, is that increasingly, I would say companies are taking the data from that environment and putting it into the cloud. And I think that creates an opportunity primarily for the intelligence side, because again, I think it's a misnomer to say that most of the customers in this space are working as operators in the environment. In my experience, most of the people that really need access to these systems tend to work either proximate to the plant or in the office domains, and they're effectively providing engineering support to the operators in a variety of ways, shapes, and forms. And over time, the amount of stuff that is being done from those quote unquote remote locations is only increasing. My view on that basis is that the cloud is a big enabler for this, because the capabilities of data processing in the cloud are just much, much stronger than they are within an on-premise environment. That said, we also at Applied recognize that we're going to have to be able to support customers where they're at. And for some customers, they're going to be, aggressively going after a cloud-based infrastructure. And for other customers, they're going to still be constrained within their existing OT domain. And we need to be able to deploy into an air-gapped environment. I think the key challenge for agentic systems in this space is there's going to be multiple personas, multiple users. And as a result, you're going to have to be able to meet the customer wherever they are on that journey and be able to support them with your system. And what that means is you need to develop systems that are both cloud ready, cloud agnostic, and also not cloud dependent. And that's actually really hard. And it's something we put a lot of thought into here.
Yep.
I would completely agree. And normally this is also if you I don't know, check best practices or read the books, they normally would probably give you the advice not to do so. But I also would agree to Dan. The engineering space is slightly different as the typical SaaS game or the cloud game there, where I don't know, it was more used to it. But at least to maybe I agree to everything that you said. I would add maybe some trends that I've seen over time. At least, I mean, we're working with a lot of large companies in the automotive space, aviation, consumer goods. Most of them, I don't know, 1 billion in revenue plus, but so they're really the larger ones. And they changed their perspective to the cloud, I would say. Um,
Mm-hmm.
and and what we see is that especially these folks, they have then, I don't know, hyperscaler that they used, I don't know, an AWS Bedrock or an Azure service where they host then inside the different models that then their IT security checked in and say, okay, this is the context we are allowed to use. And that was definitely different. I don't know if we try to bring engineering knowledge into the cloud 10 years ago or 5 years ago, right? So I think now people see also the benefits, especially when they're dealing with these new infrastructure, that it's maybe not the best strategy to do everything on your own.
Yeah.
Very true. Uh, when we think agentic AI now in your respective domains, so could you already foresee some veritable use cases that could evolve, say, in the next 2 to 3 years?
Mhm. I mean, we have customers that building today already with our technology multi-agent systems for
Mm-hmm.
their specific jobs they want to solve. And when I go with these customers and talk to them, they have a lot of variety tasks they would love to ship over to a digital coworker or best case digital department that can work hand in hand with their normal labor force. And I would always put this on a time, right? And say, okay, the technology is ready for these kind of use cases already today, this for tomorrow, and probably this for the day after tomorrow, right? And we had the discussion in the briefing room where we thought, okay, how good is, for example, the foundation model by understanding spatial geometry, right? So when a
Yep.
customer comes today to me and say, I want something like design me a new car out of scratch from nothing, just from thin air, it's probably a very hard task. When I see the current technology evolving there, they're evolving fast, but they are not there yet, at least not at the quality that we are normally design cars by hand. But there's a lot of other engineering tasks already in the now era where people can
Mm-hmm.
apply it today. And it's insane to see, for example, how much work, repetitive work, our smart engineers have to do to be consistent in their environment and to fulfill all the review process and all the stuff that they came up to make sure that they have quality and etc. pp. And we see a lot of use cases here already. And here I already would look into use cases where you normally not have one person involved, but multiple persons and multiple organizations. Normally you have some increment goes there and goes there, goes here. So one use case, for example, that we see in the automotive space is, for example, when a tier supplier wants to make an RFQ for an OEM.
Mm-hmm.
Normally, when they got a request from the OEM, for quotation, they have to involve, I don't know, 5 to 20 experts to make sure that they can fulfill all the requirements and all the stuff. And there's a lot of different tiny tasks to do. They are normally
Mm-hmm.
not making a huge new development, so they're adapting a lot of things. So they are not starting from scratch. And these are the cases where I think these systems already have huge well, they reach already the feasibility, so we see it already in action. People have it, and what we also see is that the business impact is already, yeah, far more than we expected, right? Because if you are in this area where you, for example, able to make the RFQ process more efficient, it's not just that you are saving engineering hours, you also increase the likelihood of your conversions to win more deals. And then it's even more business related, right? And this is just one example, right? So there are some
Mm-hmm.
of these examples in this now column where I would say This is not where we have to wait for the future. This is where we can act. And all the things that we discussed, right? The context, the model, the tools, this is nothing that you invest now and you have to start from scratch tomorrow. It will be an evolution, right? So what you're starting now, you can extend tomorrow, and you can benefit when the model becomes better, the context becomes better, and the access to tools becomes better, and that will unlock more use cases. But probably this is maybe a little bit different when we're looking into the energy sector or not. Dan, what do you think?
Yeah, I think I think similar actually. I think maybe I'll give a bit of history here from my own perspective. I think it's worth just touching on that. I mean, my view is that we've been doing this type of thing for quite a long time, and there's been quite a lot of proven value cases where AI has been applied to a variety of different processes in the energy space. I think if you look at predictive maintenance, if you look at advanced process optimization, real-time process optimization is often referred to. If you look at integrity management, there are countless examples. Safety management, there are countless examples where we've seen conventional AI systems delivering value over the last few years. I think for me, the agentic system is just a build on that, where it's starting to now supplement those capabilities and taking it into new areas. What I think is most interesting is that where historically AI was providing basic predictions on equipment failure, increasingly now AI is capable using these systems of diagnosing some of the most complex issues within the sector. So that might be, how do you create a new optimization path where you're able to maintain the same product quality in terms of output whilst minimizing energy consumption within a highly complex unit, for example? Or can we identify a mechanism of changing out a particular solvent within a carbon capture plant without adding in additional corrosion to the facility? Or understanding a particular parameter within the unit that historically has been very difficult to calculate because it's dynamic and subject to lab testing. So all of these types of scenarios are now things that we're actively tackling at Applied, which previously were just very difficult to do. So I think it's a journey. I think at the same time, we have to be honest and say we're right at the start of this, in my opinion. I think if you look at the industrial AI sector, my own view is that the technology is only in the last 18 months really getting to the point where you can bring it together with all the things, Daniel and I have been talking about, with enterprise context, with agentic systems, with large language models, with detailed process understanding, with physics, with time series. Those things are actually quite new. And so I think my sense is that what we're going to see in the next 24, 36 months is a massive acceleration of companies adopting this as they realize that this provides a radical paradigm shift. And maybe just, I think, I hope Daniel would agree with this. I think the key thing for me, Karthik, is that historically we've built models for specific cases. So we've built models that solve a problem. It might be valve failure prediction. It might be, compressor failure. It might be corrosion detection, whatever it may be. What's happening now is we're seeing general purpose models that can do all of those things, either through foundation models as we're doing, or through agentic systems, or a combination of the two. And those general purpose systems are going to be far more powerful and are going to force us to radically rethink the way in which we run these engineering processes.
Very interesting. Now, being based in Germany, Europe, I can't but avoid a question on governance. How do you think the governance aspect will play out? Because we need to ensure that the agents, for example, Daniel, you mentioned about an RFQ being potentially agentified in a way. So how do you ensure that the agent acts reliably? What kind of governance we need to start thinking about eventually when we get there?
Yeah. As we started with the first multi-agent systems back in the early, what was it, 2024, with some of the large automotive OEMs together, what we learned is that especially this trust, right? They need trust, right? And they need to understand what happened behind the curtains. They cannot just throw inputs in, get something, and there's a black box, and that's fine. Our whole industry is not working like this, right? And it will be the change. We are not ready, and probably we should also not be ready for it, because it's good to question things. So what we see here is a lot of things need to make sure that we have traceability, right? So we have to understand why an agent making an action and performing an action, and what is the input and output of this action, and why was it the way that they choose to do this. And that was one of the first things that we have seen that also was highly requested by these enterprise customers, to make sure that everything is traceable, right? The question is if everyone will read it at the end. Let's see it, because when this multi-agent system is really starting, it's like, I don't know, it's like a development project. What normally took months and years, they will perform it in days and hours, and you will see all the communication between these agents. It's a lot of thing, right? So the next thing, and we see it already, is all the stuff with evals, right? So we have to make sure that whatever we change in our agentic system or improve, we have to make sure it's still operating the way that we hope it's operating, right? So back to your question, it's not just developing the model and the context. You also need all the infrastructure around to make sure that we apply at least the governance that we are used to it in a way that we can really trust these systems and also get the credibility that we need, especially in engineering, right? We all want to enter a car where we feel safe, right? And this should still be our number one priority, and not just speed for everything.
That's a good one. I think, Dan, maybe I can contextualize the question a bit. So do you foresee a situation where agents in the energy space are categorized like what we have in the conventional safety integrity levels, like SIL 1, SIL 2, SIL 3? Do you foresee something like that, just from a governance standpoint?
Well, I think there's probably a couple of things. I think I do see us heading that direction, very much so. And the reason I see us heading in that direction is because you already see the EU AI Ethics Act taking us in that direction. And I think for most of us, who work in Europe, and obviously, whilst I'm based in India at the moment, a lot of our work is in Europe. We're going to have to take that into consideration. We're going to have to comply with the regulations. We're going to have to make sure that our systems are aligned to what the intent that the regulations are driving towards. And by the way, I fully support it. I think it's, as Daniel was saying, it's absolutely fundamental. You can't just put hallucinatory systems into engineering context. It's just not, it's not acceptable. It has to be right. So I think that's a given. So I think, will it be as formal, Karthik, as that? I don't know. Okay. I think it might look different. I think, or at least I would hope it might look different. I'm not saying it will. And the reason I say it might look different is because I think by nature, what we don't want to do is apply traditional checking mechanisms to a computational environment. And I would argue there are better ways of verification, if that makes sense. So I think that's probably, where I would start anyway. I think, back to what Daniel was saying, though, I think there's probably a bunch of principles you can extract that have to be there in any verification system. The first one is being able to accurately explain what it is that you're deciding or doing. So that explainability, which of course we all know is not easy within an AI context, that explainability, I think, is fundamental. I think the second thing is, not going beyond competence. And that's actually a challenge with LLMs today, is that they tend to speak knowledgeably about stuff they have no idea about. And I think that ability to constrain the models within their areas and domains of expertise as part of the agentic system is going to be very, very important. I think the final thing is being able to verify through human expertise. And I'm a big advocate, particularly in energy, that we are going to want for a long time human in the loop. The reason being that I think there's too much uncertainty in some of these processes, and too much variability, that trusting the machine completely with the execution with no human checks and balances, I think is going to be hard. And I think the push towards autonomy in some of these most complex engineering environments is probably premature. What I think is right is the push towards more intelligent operations. In other words, more data, more information being provided to key decision makers at key points in the process. And to your point, less manual data munging. and manipulation of data points in spreadsheets or other tools towards as Daniel said, more of an integrated Jarvis-like experience where engineers have true visibility of how their process is operating and can use AI and agentic systems in particular to start to control and push the system in the right direction when it goes off course.
Very good. I think this has been a very intense, profound discussion, and we've had a lot of intense, profound questions as well. So I'll really move to that. I have a few more. If I have time at the end, I'll chip them in. Uh, okay, very good. So I'm going to go based on the order in which we received them. I think it is this is one from Charles. I think it's for you, Dan, from Applied Computing. So for Dan, being from the energy sector, please explain the difference between APC models that control complex processing and AI. Many
Yeah.
companies have struggled to apply APC methods above their basic process control. So how will they move to applying AI in production where system level meta models are very disparate?
Yeah, great question. And this could be an hour, Charles, in this particular topic. So I'm going to try and keep it very brief. And I'm also going to try and keep it relatively simple because I know that this can go over the head of some folks in the audience because if you're not familiar with the sector, this is a bit unusual. A lot of the energy units that we rely on, so in refineries or in LNG plants, for example, they tend to use something called advanced process control. And what that does is it effectively optimizes the set points within the engineering limits for the operation of that facility. So in other words, it will dynamically optimize what the distributed control system is doing to maximize the throughput within the limits that have been defined. Behind that technology tends to be a set of nonlinear solvers, mathematical equations that calculate those optimal set points in real time. The big challenge, and Charles, you alluded to it, is that these systems firstly have to be very, very carefully checked by the engineers through a process known as step testing, which effectively is looking at, as we look at these optimization limits, how can we make sure that the maths doesn't violate the physics and we end up pushing the system into a zone that is not safe for the system to operate in. And this is often why we struggle to run these advanced process control units or these advanced process control systems at scale, because either one of two things happens. One, they end up being quite static because the step testing takes a long time, or alternatively, people stop using them because the issue is that in continually maintaining it, it's just too difficult to continue to go through these step testing approaches in these dynamic environments. The interesting thing about AI, and in particular physics-inspired AI, is that we believe it can solve that problem. Because if you can create an AI system that understands the physics, as well as understands the dynamic operations of the time series data that's coming in continuously, deep learning by its nature is a very good universal function estimator. And it acts by nature in a nonlinear way. And so as a result of that, you can find optimum set points in the same way that an APC would, but you can constrain it within the physics that the AI has learned. Now, this is what we're trying to do at the moment. We have a number of examples showing that it works. What I will say is conventional AI struggles because it doesn't have the physics in it. The key element is that without the physics, this is very hard to do. And that's why I say it's only really with the latest breakthroughs in physics-inspired AI that you're able to start attacking problems like this. That was quite a complex answer, Karthik. And Charles, very happy to follow up offline if there's more interest in that particular topic.
Thank you, Dan. I think the next one is from Kevin, and I think Daniel, you can take this one. How do you convince, especially the cybersecurity folks, to adopt and bring in, say, an LLM model for use of in-house data sets and build an engine for custom AI?
Yeah, good point. I mean, in all of our customer engagement for sure. So at one time, IT/cybersecurity or also data protection kicks in, right? And they want to be part of this journey. And I think it's also very important to design a system with them and not around them, right? So to make sure that you get this trust also from these folks. always with the, let's call it, balance between, okay, what maybe we need to change, and maybe what we still need to apply, as I think, Dan, you mentioned it, right? We have to bring the technology at the state where the customer is, right? Sometimes it's very difficult, right? And they should also accept it, that maybe an air-gapped situation is harder to deploy than than a cloud one, and it costs maybe more time, more effort, and more onboarding. But they have to decide where they want to put the needle, right? How much control do they want? And again, I think what we see, it changed a little bit, this kind of assessment over time. But then there are normally the classical questions, right? They want to understand, okay, what's happening with my data when I incorporate with a model that is not hosted in an isolated network, right? How can we audit it? We had this question with governance also. So how can we make sure that we have the traceability, the log, how to build it, how to see it, that they feel it, that it's nothing a black box? Or Dan mentioned also the hallucination, right? So how can we make sure that we avoid hallucination? Because everyone had probably self-experience when they use ChatGPT in a field where they're experts in, and say, "Oh my God, yeah, but sounds confident, but it's wrong." And I think here we have technologies like the layer that Dan described, or guardrails, or any kind of other technology that you can try to apply to make sure. I mean, first of all, I think it's important that everyone is aware of this, right? And also that the cybersecurity team, together with your application engineers, are aware of it. And then you can decide what kind of strategy you would like to apply for it. The good thing is, as this whole movement, the whole agentic AI now is so big in all different technologies, all these different questions at the moment get improved weekly, I would say, right? So there are thousands of new things you can apply to work on cybersecurity if you want, right? And there are best practices already. So I always suggest to have a good middle path between make sure you know what's happening versus, okay, everything need to be on one PC, best case.
Very good. I think we have a few questions. I think this is for you, Dan, from Mayank. Uh, who are the clients you've been working with specifically in refining? And what solutions have been deployed and what kind of business outcomes have been delivered?
Yeah, great question. And what I will say is it's always difficult to name customers in public forums, so you'll forgive me for that. But I can certainly talk about the use cases that we're working on, and the value. I also want to say something in true humility and transparency here, and I said this at the start. For the sort of technology that we're developing here, it is early days. Applied computing's only really been deploying stuff in the real world, as it were, for about just under 12 months. And so in that sense, it is early days for this, and it's going to grow over the next few years. That said, we have some fantastic examples demonstrating that it works. And just a couple off the top of my head that I can throw out there. We just completed a project, I sort of alluded to it earlier on, where we're looking to work with a particular refiner to look how we can. They're running their unit above nameplate. For those that don't know what that means, is effectively they found ways of optimizing their unit beyond what it was designed for. And it produces a particular product with a particular specification. And alongside that, they have a high energy consumption because they're pushing the unit to its limits. And the question that they're working with us on is how can we find new optimization set points? So going back to the point I made around advanced process control, what they're trying to figure out is actually, we don't really know what zone we're operating in because we've already pushed the unit beyond what it was designed for. We know what it should be operating in. We know what we can get out of the unit. Can you find us new set points within this environment that allow us to reduce the energy consumption, maintain the product quality, and bring the whole operation closer to the engineering limits we'd like to be within? So it's a really good example of a use case that we're trying to work on where it's kind of exactly the sort of problem that's very, very difficult for conventional methods to solve. But with AI, you can start to explore this in very new ways. So that's one example. Another example, I'll move out of the refining space. I'll move into the upstream space. We're working with an upstream customer at the moment where we're looking to help them reconcile their entire production system using physics-based AI. For those that don't understand the upstream system, very, very complex, lots and lots of pipelines, fluids, fluid gas, so oil, water, gas, all coming together, all flowing through a variety of different pieces of equipment from the well to the beach. very hard to reconcile because it's a very, very complex physics system. You get shrinkage, you get losses, you may have trips, the wells change their production levels. So being able to actually say how much of each am I producing is quite challenging. Now, when you bring a physics-based AI engine into that environment, you can start to rethink the way you do that completely because you can start to reconcile, develop soft sensors based on that AI, and then be able to provide a much sharper recommendation as to what exactly is being produced at each point during the value chain. So just a couple of little examples of things that we're doing at the moment, but hopefully that gives a sense of where this is going to drive value in the future.
Very good. And I think we have one more question from Mayank. So as a leading startup in your sector, which kind of Gen AI and agentic AI partners from the software and the IT engineering services side you feel can improve value for your solutions and improve penetration into refining as well as other energy sectors? I think the question is basically, do you see a scope for ITES or IT service providers who can partner with you to expand your market reach?
I'd love to hear Daniel on this one as well, because I'd love to get that perspective too. My own view on this is as a startup, you have to be very, very focused on what you're doing. Our focus is on building a foundation model for the energy sector. To be very focused on what you're doing, you have to also know what you're not going to be good at. And there's a lot of work that needs to be done to integrate data, to link to systems, to create connectors, to do change management, to be able to build foundational data platforms, to build cloud architectures. And so what we're trying to do is make sure that we are the best in the world at building an energy foundation model, and that we work really well with others who are better at some of these other skill sets within the end-to-end that we have to solve to deliver our customers' outcomes. So I'm a big believer in partnering. That's our strategy, and to make sure that we work really with anyone who wants to use our foundation model. So that's my view. Daniel, interested if you have a different view of how you see this.
Do everything at once. No, I'm kidding. I mean, for sure. I mean, especially a startup, it always seems you have unlimited resources, but it's not, right? You have very limited resources, and you have to make sure that you have the highest leverage effect on that, so to get next rounds. And yeah, so when I look at our niche and focus, for us, it's definitely the tool layer, right? So we helped engineers to digitalize their work, what they normally do in single tools, and make this digitalization of work statement executable. And these are like the tool layer for the agents now. And I agree to Dan, there are so many topics around the agent one, right? Where others are much more suited for
Yep.
us. We are not the expert when it comes for, I don't know, when someone calls also from other industries where we are not very happy in it, we're also saying no. I mean, there are other great technologies, go for them. But whenever you have, I don't know, mechanical engineering tasks and you want to make digital coworker in the space that they use the tool that you are normally used to, then you have to, well, not you have to, but I'm happy to get a call from you and discuss opportunities here. But in general, I mean, I think focus matters. It's one of we have 5 core values in the company. One is we say no to everything that is not part of our strategy. It's, but also the hardest value to live, right? Because as a startup, you also see a lot of opportunities. There's a lot of green grass on the other side, and you say, oh, why not this as well? And look at that. But yeah, definitely stick to your unique selling point and make this even more stronger.
Very good. I think, Julieta, we could go to the live question.
Of course. So Charles is asking a live question. Let me unmute Charles. Charles, you are live. You can ask your question.
Hey guys, thank you. So I'm a master black belt in Lean Six Sigma, 28 years, and worked across 10 manufacturing systems, and I'm the chief editor for ISA 95 IEC 62264, which people use as an ontology for models and have for 20 years. But how you get to an agent and what that person needs, I've basically done by doing failure fixed mode analysis at the process level, equipment level, and the various workflow levels from going up through the operational layers. So, I mean, at the end of the day, if you're going to create an agent, you need to prioritize the use cases and the responses for those use cases. So I'll stop right there.
Thank you. Thanks, Charles. I think we'll keep it very brief, Dan, if possible, and
Yeah.
Daniel as well. Mhm.
Yeah, Dan, go first. I think you're more an expert on FMEA than I am.
I'll keep it brief. And Charles, I'd love to talk more about this. I think what's interesting, right, is that so if we look at statistical process control, and I also started my career in Lean Six Sigma, so I completely get where you're coming from. And by the way, this has also been some of the things that I've been wrestling with as I go through. I think the big thing to recognize is that the modern transformer architectures within AI can actually make predictions at multi-layers within the environment and do that simultaneously with high degrees of accuracy. And it's almost as though the more data you give it, the more accurate it becomes. And that's kind of the whole thing about the attention is all you need paper. And if you haven't read that, I would encourage you to have a look at it. The key thing on top of that is if you can combine that with physics and a contextual understanding, which Daniel was talking about, you can start to change the game in this space, because you can actually, provided that you don't get too crazy with the problem statement, you can start to solve a lot of the things you're talking about in parallel versus in series, and to look at the whole system in an integrated fashion from a single model perspective. I know that sounds crazy, but actually there's a number of companies out there that are doing this now. And I think it's very much something that is going to change the game around how we do, in particular, failure mode analysis, because you can start to look at anomalies plus explanation at scale.
All right. I think we are well ahead of time. Dan and Daniel, thank you very, very much. This has been a very intense conversation. I should be honest, I still have to spend some more time to understand some of the insights both of you shared in this last 1 hour. Um, it's been a delightful, I would say session. I'm also sure about that for the audience, and I'm really looking forward to hosting you again in another interesting webinar. Maybe we go a bit more deeper into agentic AI. I think in that case, I think I have to send some reading material to the audience just to ensure that they come prepared. Thank you very much to both of you.